just figures. All right, so our points were, our x, we went from 0, at 0 it's 3. At an x of 1 it's 4. At an x of 2 it was 7. And at 3 it was 12. I'm going to go off, right? But do you see that there's a parabola? It's not the whole parabola, but is it a piece of the parabola? Now, what does this mean? It means this was at time equal to 1. That was at time equal to 2. This was at time equal to 5. Have I described the path of my particle with time? So how do I get that equation from, if I wanted to get the equation from the parametric, I need to substitute in. I need to solve for t and do a substitution. That's the easiest way to do this. I wouldn't recommend solving for t and sticking it in there. It's going to be so much easier if I solve for t out of this one. I want to get rid of that radical. Do you understand what I'm saying? It's going to be so much easier if you'll get rid of the radical. So if we solve for t, do we get x squared equals t minus 1? So t is equal to x squared plus 1. If we go to the y equation, the y was t plus 2. So that's y equals x squared plus 3. Is that the equation for that graph? It is a parabola that's been shifted up 3. Notice 1 squared is 1. 2 squared is 4, and does it work? Yep. So that is how we get between them. Now, the one thing is, there's a catch on this. Do I have to restrict my domain in order to match that graph? What's the restriction on my domain? X is what? Look at our graph. Yeah. X is greater than or equal to 0. And that's my parametric equation to my rectangular coordinates. So you're supposed to be able to do that so that, and oh, one more thing. This has directions. Notice I drew that. That's not just going to infinity and beyond. This whole thing is moving this direction. That's time 1, that's time 2, that's time 5. It is moving in that direction. So you have to indicate the direction things are going for parametrics. All right. Next one. You can make a table, and then you can solve for the equation. So first we're going to solve for the equation. This time we're going to do a little different, and then we're going to solve for points to graph. So I'm going to solve for t. Would it be really easy to solve for t in this equation right here? I don't have a radical. I'm not worried. So this is t equal to y over 2. So that means x is equal to y over 2 squared minus 3. That becomes y squared over 4 minus 3. But they gave me a restriction on my time. So before I can do that, I gotta go back here. Notice my variable is y. Could I plug those into the y and find the restrictions? So we're going to take these and we're going to plug them into the y equation. So what are my restrictions if I put -2 in there? If I'm starting at -4, less than or equal to y, less than or equal to, plug 3 in there, is that 6. So is my particle moving between the time is -2 to 3, but the y coordinate is from -4 to 6. So what does this thing look like? Is that a sideways parabola that has been shifted left 3, and because it's divided by 4, does that mean it's wider? Yeah? Okay, so let's go ahead and get some points for this. We're going to choose times wisely. Well, actually, it makes it really easy because they gave us restrictions. I actually prefer those. Makes it easier to figure out. They want me to go from -2 to 3. I'm going to do it steps of 1. -1, 0, 1, 2, 3. If we plug in -2 into the x-coordinate, it's -2 squared minus 3 is 1. If I plug in -1, that's -1 squared is 1, minus 3 is -2. If I put in 0, it's -3. And for 1, 2, and 3, does it matter? Because it's squared, is it going to be the same as the corresponding negative values, right? And we put in 3. 3 squared is 9, 9 minus 3 is 6. Do we have points we can graph? Yep. Let's go to the y now. Plug in -2, we already did that, it's -4. And 6 we already know, 3 is 6. And then we're going to plug in -2, that's negative, we're going to plug in -1, that's -2. Plug in 0, it's 0. 1, it's 2. 2, it's 4. And 3, it was 6. And we can graph these points. So when time is -2, our point is going to be 1, -4. When time is -1, it's going to be -2, -2. Then at time 0, it's going to be -3, 0. And then we go up. Oh, they're not including that one, are they? I got lost. No, it's right. And then the last one is going to be at 6, 6. So those are my points. Which way did it go? Where did it start and where did it finish? So it started down here and my particle went like this. Oops. Stop. You don't go past it. So this is at time, this is time equal to -2, time equal to -1, time equal to 0, right? Time equal 1, time equal 2, time equal 3. So is it going in this direction? This always reminds me of two things. One, it's orbits, like of planets and moons and all that kind of stuff, when they show the time when things will be someplace. And I remember seeing something in one of the Apollo movies where they were plotting out where they would be in any given time. It was a graph like that. All right, next one. Oh, fun with trig. All right, do y'all want to solve for it first, or do y'all want to graph it first? I don't care. Solve? Okay, solving it is. Here we go. So, yeah, you have to know some basic trig to do this one. Yeah, that's just going to be fun. Okay, to solve for t, this one's, I'm just going to show you the trick. So I need to get this by itself, and I really don't want to do inverse cosine. So I'm just going to cosine x, cosine t by itself. So do we all agree that we're going to subtract 3 from the x and then divide by 2? So cosine of t is equal to x minus 3 over 2. And for sine, I'm going to get sine of t equals y plus 1 over 3. Agreed? All right. Here's what we're going to do. Do we know any trig relationship that relates sine and cosine? Yeah, so Pythagorean theorem, sine squared of t plus cosine squared of t equals 1. So what I'm going to do is, I'm going to go, okay, y plus 1 squared over 9 plus x minus 3 squared over 4 equals 1. What kind of graph is that? Conic sections. Huh? It's ellipse. And it's ellipse where the height is more than the width, right? So it's oriented long side, up and down, skinny side, right and left. Remember that? Sort of. Okay, what is this? Where's the center of this thing? Do you know what the center is? The center is the HK. There's H, there's K. So it's in its opposite, so it's going to be 3, -1. And then this tells me that I think y'all used A and B, right? B is equal to 3, and for this one, A is equal to 2. So it's centered there, and the width is 2 and 2, and the height is 3 and 3, above and below. So I can graph it without doing the whole parametric thing. I mean, I know that my center is here. I know I have to go up 3 and down 3. I know I have to go right 2 and left 2 from the center, and it's ellipse, right? Yeah? I really don't want to go do the table. I really want to just use what I know about algebra and conic sections. So much easier. Do you understand what I did? This is my A and this is my B that I went over here and got. It's from the denominators. So the other way to write this, normally the way y'all would write it, y'all would write x minus 3 squared over 4, which I could write as 2 squared, right? Plus y plus 1 squared over 3 squared equals 1. And that's where I'm getting my links from. Now, where is it starting? What did I do? Oh, I wrote A's and B's. Where did I start? What is at time 0? At time 0, what's cosine of 0? 1. And what's sine of 0? 0. So is this term going to go to 0? Right? Correct? I know this part's going to go to 0. That's going to be -1. Yeah? And then this is going to be 1. Is that going to be no, 5. So is that this point right here? Is that my start? This is time equals 0. So we're not going to exactly make the table. We're going to sort of just do some quick. So if I have time equals 0, my x is equal to 5, and my y is equal to -1. Yes? And we're going to pick nice, easy ones, right? Yeah, we want easy, don't we? So at time equal to pi over 2, because I want it to be easy to evaluate. So at pi over 2 is the sine 1 and the cosine 0. Yeah? So my x is going to be 3, and my y is going to be 4, yes? Where's 3, 4? It's right there. Well, 3, it's not 4. I did that wrong. Because it's -1. It's 3 minus 1 is 2. Sorry, 2. Is it this point right here? So is it going this way? So this is time equal pi over 2. And so it's just going to go around like this. It's going this way. You just need to do a couple of points and check it. So that's just basically graphing and eliminating. You want to eliminate the time and get in terms of x and y to graph it, but they expect you to be able to go back and forth. In college, on the AP test, their problems are really straightforward. But if you don't understand what you're doing, it's going to make, they could ask a question where if you didn't understand what was going on, where you wouldn't know what to do. The calculus is easy. What?
Would we ever need to know, because you said like the explanations for the stuff before, like we don't really need, right? They would never.
Not for the AP test.
Okay.
This is for beyond the AP test.
Would they need that in college?
Yeah, if you're taking college, if you're taking physics, like the more advanced physics, if you're doing trajectories, you kind of need this. And in your college calculus classes, I'll be very honest, they're going to do more of this. But they'll teach you what they want you to know. They know that high school conic sections suck, and they'll teach you what you need to know when you need to know it. All right? But for purposes of the AP test, I'm showing it to you. It is a college thing. It helps to understand this so that they can't ask a question and trip you up on just the whole underlying concept. The calculus for this stuff is easy. It's really easy. I'm just afraid one of these days they're going to ask a question where it's still the easy calculus, but if you don't understand the concepts behind everything, they could trip you up. All right? So, just real quick review of that before we go do calculus. What, dear?
For part B, how do you know when to restrict the domain or when to restrict the range? Because for that instance, you restricted the range.
Well, it did, but is the domain restricted as well?
Yes, but
But what?
like,
Why did I pick Y? Because it's the dependent variable.
okay, all right.
Remember that? I said that. I'm picking Y because it's the input. I'm going to restrict it. Okay? Got it. Okay. All right, so that's parametrics. Now we have to do polars real fast. And polar is at the door, right? There was no polar at the door? No. Yeah, okay. They haven't got that far. We may not get that far. It's after their TEACS test. It's like, I just work here. Okay, so on each one of these, I'm not doing all this. I'm going to go through some things for you, and then y'all can practice it later. Or not. So we know how rectangular coordinates are x and y. Polar are r and theta. Do they give you the same? Can they just, when we describe the same point both ways? So what you need to know is if they give you a point, and why am I doing this? Not so much this, is because to understand the polar calculus, you have to understand the graphs of polar. And the only time you've done polar is with a calculator, correct? Did they make you do anything by hand? Oh, they tried. Okay. Okay, shush, I don't need specifics. Just, okay. Just a quick review. If it's polar, if I tell you these are polar, can you tell this is polar? Because look at that, it's radians. Yeah. So what you're going to do is you're going to go for every single one of them. This is a radius of 4. The important thing is how in the heck do you handle negative radii and negative angles? Negative angles are obvious. With positive angles, we go counterclockwise. Negative, we go clockwise, right? Radius, the negative radius. We're gonna do A, and then I'm gonna do something with A. So first for A, if I want a radius of 4, it's 1, 2, 3, 4, right? So if I was to highlight it, 1, 2, 3, 4. Actually, I've already done polar for pre-cal. You're right. Never mind. Forgot I did that. It was painful. Okay, so that's a radius of 4, yes? Oh, hang on. Y'all can't see that. Radius of 4. Where's the angle of 2 pi over 3? Do y'all remember any of that? Oh, it's labeled. I know, it's labeled here. Will it be labeled on the AP test? No. It won't be. They're not going to give you a unit circle. They're going to give you a graph, or they're going to just give you an equation. So is this point A? Shh, shh. If I take point A, and instead of A, I'm going to do A. I'm going to do little. No, I'm going to do alpha. Point alpha is negative 4 2 pi over 3. What happens to get alpha? You go 1, 2, 3, 4. This is alpha. So you know how with negative and positive on the rectangular coordinates, the negative value is on the other side of the origin? For a negative radius, it's on the other side of the origin. So when you go to do C, is it going to be on the other side of the origin? When you go do D, is it a negative pi over 6 instead of a positive pi over 6? That means it's in the fourth quadrant. So y'all go graph points by yourselves. Y'all can do this. The key is up there. All right. Things you should have learned in pre-cal. So it's based on, that's right, the triangles. This is our angle. This is some radius. You did a unit circle. The unit circle's radius was 1. That's why it's called the unit circle. This is y. This is x. Yeah? So, based on SOHCAHTOA and this triangle, notice this is my reference angle. Is y opposite or adjacent? Opposite, adjacent, hypotenuse. Cosine is what? Opposite over, right? Cosine is adjacent over hypotenuse, right? So it's x over y. Sine, you learned all this in pre-cal, right? Sorry, over r, r. Sine is y over r. Tangent is y over x. X squared plus y squared equals what? R squared. So if you know that, can you solve for x from this? What's x equal? R cosine of theta. I cannot tell you how important that equation is. If you don't remember that, you won't be able to do the calculus. Are you listening to me? Because there'll be problems where you have to do this, you have to do this. So what's y equal to? R sine theta. You have to know that one. So what's r equal to? Solving from here. To be able to go back and forth, do you need those? If you don't have those, this one too, this one's important. That's going to come into play in the calculus. Well, sine and cosine, not so much. But the other ones, you're going to have to go backwards and forwards and do things, and you're going to need those. Really, really. They're not going to tell you them. They're not. They're not going to tell you what x and y are. But are they going to make you find dx, dy, dx? Yes, for polar. Uh-oh. Okay. Converting points. Look at this. You have a radius and you have an angle. Can you find x's and y's? What two formulas are you going to use? This one and this one. So I'm just going to write them out. X is equal to, what's your radius? 2 cosine of 5 pi over 6. Y equals 2 sine of 5 pi over 6. Is this why you were supposed to memorize your unit circle? This equals negative square root of 3. You can go figure it out on your own. This equals 1. Go do the math on your own to make it match. If you can't do the math, go figure it out. If I have a point 3, negative 3, that's rectangular, I'm converting to polar. That means it's rectangular. So I go up here and I have x and y. Can I find everything else? So the one thing that's not, see why I circled this one? Do you see why? Can I find the angle from it? Right here. What is the angle equal to? Tangent inverse of y over x. Is that why we need to know that one? And how do you get radius? That one, right? So, to get radius, that's the easy one. It's the square root of 9 plus 9, right? Which is going to equal 3 square root of 2. Yeah? Doesn't matter if you say yeah or not. So theta equals tangent inverse of y over x. Well, y is negative 3, x is 3. Where is tangent negative 1? And the thing is, so if we're doing inverse tangent, so if you're technically doing inverse tangent, it's only in the fourth quadrant, and that would be negative pi over 4. But when you're talking about polar coordinates, you got to think in terms of the whole unit circle. right? Do you know that? So in actuality, that's strictly for the inverse. If I'm just doing inverse, if I do tangent of theta is equal to -1, then my theta could be, if I don't write as inverse, if I'm just solving for this, could it be the -π/4, and where else could it be? Right? Because it can be anywhere on the unit circle between 0 and 2 pi. Well, that's -π/4. I'm not going to write it that way, am I? If I'm using the regular unit circle, is that going to be 7π/4? And where else is it going to be equal to -1? How about 3π/4? You understand what I'm saying? Technically, inverse tangent is only defined in the fourth and first quadrant, but we're talking about on polar graphs, we're talking about all four quadrants. Okay? That's a calculator thing. This is a brain thing. You have to use your brains.
If you put -5/4, would that be wrong?
Huh?
If you put -5/4, would that be wrong?
Okay, when we're talking about polar graphs, we are graphing between 0 and 2 pi.
Yes, so it would be wrong.
Yeah. You just need to be really, 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 really careful. I mean, probably they would accept it, but I'm just saying, technically, they'll have to. Okay, converting. If we have a line, that's a horizontal line. What's it going to look like on a polar graph? How do you get a horizontal line? What was y equal to? R sine of theta, right? So r is equal to 4 over sine of theta, which is 4 what? What's the reciprocal of cosecant of theta? That equation would get you a horizontal line. What kind of graph is that? That's rectangular. What kind of graph is that? Circle of radius. If you know that, then you just tell me the equation is r equal 5. How do we solve for that? Oh, just take the flipped square root of both sides. Because what is r equal to? Isn't it equal to the square root of x squared plus y squared? Oh, stop. Okay. So this is converting these. This is going the other direction. Oh, okay. Just a minute ago, did we just use this? What is this equal to? Y. So is that a horizontal line at 3? This one's a little messy. That one's not so good. Unless, of course, we square both sides. Or actually, I'm going to multiply by r. Okay, what am I trying to do? I'm trying to get this in terms of an x. Do I need an r over here? Yeah? So if I multiply the whole thing by r, do I get r squared equals 2r cos... Oh, sorry. No, I did actually want that. I want 2 times r cosine of theta. I'm trying to make sure y'all see that. What is that equal to? So, is this just... And what's r equal to? X squared plus y squared equals 2x. Yeah? This is some sort of circle. Do y'all remember completing the square? Did y'all ever complete the square? If you took scholars, you'd learn to complete the square. We're going to move this to the other side, right? We're going to subtract 2x, so we have x squared minus 2x, and we're going to complete the square for this one, and then plus y squared, which we don't have to complete the square for because it's all okay, it's all good, right? And then this has to equal 0 because I moved everything over, right? Well, b is -2. -2 divided by 2 is -1, so this is going to become x minus 1 squared plus y squared. To complete the square, I have to square the -1. It's plus 1. I have to subtract 1 out on the outside. Yes. Swing that on the other side, that becomes 1. So my equation is a circle of radius 1 that has a center of 1, 0. It's this right here. So it's a circle. Oh, I didn't mean to do that. It is a circle centered here with a radius of 1. Is that my circle? Clever things you were supposed to remember. me ask you a question. On a polar graph, if the angle is always the same, they only give you an angle, does that mean all radius are possible? All radii are possible? Where is this angle? Is it up here going like this? Are all those radii possible? Are all these negative radii possible? So anytime you see an angle like that, is it a line? We could solve for this because it is the tangent of 2 pi over 3. What is the tangent? That's equal to y over x. What is the tangent of 2 pi over 3? It is negative square root of 3. That means that y is equal to negative square root of 3x. Is that a negative sloped line just like I drew? Okay, talked as fast as I could. One more thing. You were supposed to do all those polar graphs. You know the polar graphs? Like those. We were supposed to do this worksheet where it was a Christmas thing, and then a bunch of y'all didn't pick it up. It's still out there at the end of the calendar. And the reason I really would like you to graph enough to get a feel for it is because if you understand how things are graphed, then when I do the calculus on this next week, I think it's Tuesday, I have to look on the calendar. We'll look on the calendar in a minute. Tomorrow we're doing parametrics and vectors. Parametrics and calculus. I don't know how many days I spent on that, probably only one, because it's really easy. Next we're going to do polar and calculus. So imagine, so what I'm going to do, let me add a page, hang on, come back here, come back. Let me add a page to this so that I can, I'm just going to show you what why you need to know this. Okay, so on polar graphs, when you were graphing them, if you graphed them, so what do they look like? They're all kinds of funky things like this, where it starts here, goes all the way around like this, comes in here, and comes back there. Lemniscon. No, cardioid. No, lemniscon. Yeah, lemniscon. Lemniscon. It doesn't matter what it's called. The whole point is, what will the AP test ask you? They'll ask you for the area inside the big loop and outside the inner loop. They will ask for this area right here. And the problem is the way this thing is graphed. Let me show you how it's graphed. You know how we just did the parametrics? Here's where it starts. It starts here. And then it goes to here, 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 comes to here. Then it does the loop and it comes here. If you integrate between 0 and 2 pi, you will get all of this area all the way to here, then you will get this area again. So you get the loop twice. So even if they wanted the area just inside the outer loop, you would get it wrong. You have to know what's being graphed where, and that's where we're going to get to. And they'll also ask you for arc lengths. What's the length of the curve? If you don't know what part of the curve is being graphed where, how are you going to find the right length? Do you understand what I'm getting at? So the key to polars is knowing what is being graphed. So where is it going to start? And you don't need to make these very pretty. I need a point here, a point here, a point here, a point here. Why am I picking those points? 0, pi over 4, right? And actually, pi over 4 is not always good. It's one of these, whatever it gives me for whatever. Okay, by the way, see the symmetry here? Do you realize that this one's in terms of sine? If it's symmetrical about the x-axis, it's terms of cosine. So if this is in terms of sine, what points do I want? I want 0. I want pi over 6 because it's sine a nice number at pi over 6. I need pi over 2. And if you really wanted, you could just do 0, pi over 2, pi. And then you have to be a little careful in here to get enough points so that you could see you're in a loop. You should practice some. It makes the area problems a lot easier. Really, really. And then for roses, you just need to get the whole, if it's even, odd. If it's even, right, that's the number of petals. If it's odd, if you're not, okay, we'll get to it. But I'm just saying, it matters. If you're doing an odd and you integrate between 0 and 2 pi, you're going to get twice the area you need. Just saying. If you understand it, but you don't do that for even pedals. It only works for odd. So a basic understanding of what graphs how and when, just overall, will help you tremendously. Okay? And if you practice graphing, if you just at least get zeros and ones and halves, do you understand what I'm getting at? Anytime cosine is 0, 1, or a half, or negative 1 or negative half, sine is 0, 1, half, or negative half, you can get a feel for the graphs really fast and easy. Okay? But y'all need to practice, because if y'all no practice, it's going to be hard to do the problems.